Okay, lecture 4. Today we're going to talk about subsets. All right, so let me give a definition here. Suppose A and B are both sets, okay? If every element of set A is also an element of set B, we say A is a subset of B. Okay, and we write it like this. A, here's the symbol for subset, B. Okay? Another way of saying that is saying that A is contained in B. So always remember that. I'm not going to put that one in writing right now, but always remember that if you hear that A is contained in B, it means that A is a subset of B. So every element of A is also an element of B. Okay? All right. How would you show that one set is a subset of another? Well, you would just go right by the definition. You would show that every element in the one is included in the other, is contained in the other. Okay? Every element of the first is an element of the second. But let me ask you this question. How would you show if A is not a subset of B? How would you do that? Okay, so let's think about it. If A is not a subset of B, then doesn't that mean that there has to be an element of A that is not an element of B? So in other words, to show that a set A is not a subset of B, you only need to find one element of A that is not in B. Let's look at some examples. So I'm going to write a few sets here. Let's call this one A. Let's write set B. And then let's write set C. Okay, and let's decide. Actually, you know what I'm going to do? I'm going to change set C. Let me write that one instead like this. Let's just write 2, 5. Okay, so let's figure out which sets are subsets of others. Okay, so let's look at A. Is every element of A in the set B? Let's ask that question. So let's go one at a time. So there's 2. Is that in B? Yes, it is. Here's 5. Is that in B? Yes, it is. Here's 7. Is that in B? No, it is not. So A is not a subset of B because there's an element of A that's not an element of B. So that means it is not true that every element of A is also an element of B. So we would write this. We would write A is not a subset of B. Okay? Is A subset of C? Let's ask that question. What do you think? I think the same problem is going to happen. 2 and 2. So 2 is in A and it's also in C. 5, whoops, I'm sorry. Let me fix that. Darn it. 5 is in A and it's also in C. 7 is in A, but 7 is not in C. Okay, so A is not a subset of C. Okay. Let's look at some of the other sets. Okay. How about this? Is A a subset of anything that's written here? So there's 3 sets written. Is A subset of any of those 3? Well, 2 is in A, so 2 is in A. 5 is in A, so 5 is in A. 7 is in A, so 7 is in A. So everything that's in A is in A. So doesn't that mean that A is a subset of itself? It is. And in fact, wouldn't that be true about every set? Every set has to be a subset of itself, right? Because the elements in that set are elements in that set. Okay? So we can automatically say for B and C, we can say similar things. We can say B is a subset of B, and we can say C is a subset of C, because every set is a subset of itself. Okay? Let's look at some other possibilities, though. Is B a subset of A? Well, it's not, right? All I have to do is find one element in B that is not in A. There's a 1 that is in B that is not in A. So B is not a subset of A. Is B a subset of C? No, same problem. 1 is in B, but it's not in C. So B is not a subset of C. How about C? C is a subset of itself, of course. Is it a subset of A? Let's check. 2 is in C, and it's also in A. 5 is in C, and it's also in A. So everything that's in C is also in A. So C is a subset of A. Okay? What about C with B? 2 is in C, and it's also in B. 5 is in C, and it's also in B. So C is a subset of B. Okay, you see how that works? All right, now, since we've realized that every set is a subset of itself, then that takes us into a new definition, which is the word proper subset. Okay, so if A is a subset of B and A does not equal B, then A is called a proper subset. Of B. it this way. Like that. Okay? We're going to use that for proper subset. Okay. Now, let's talk about the empty set. Let's just write down a set A. Okay, well, in fact, we can use the same one. Let's say A is the set containing 2, 5, and 7. Let's write that down again. Okay, now here's a very important question. Is the empty set a subset of A? Is every element in the empty set an element of A? I want you to think about that for a second. Okay, so the question again is every element of the empty set also an element of A? Okay, now if you say no, then I'm going to ask you, oh really? Show me an element of the empty set that's not an element of A. You're not going to be able to do it, are you? You can't produce an element of the empty set that is not in A. So therefore, you can't tell me that the empty set is not a subset of A. Okay? So what's that mean? It means that the empty set is a subset of A. Let's write some of this down. In order to say that the empty set is not a subset of A, we must do what? We must produce an element of the empty set that is not an element of A. And we can't do that. There are no elements of the empty set. So we can't do that. Or let me actually say it this way. I want to say that that's impossible. Okay, so what's that mean? That means that this statement, the empty set is not a subset of A, is false. So therefore, the empty set is a subset of A. Okay? Now, somebody once asked me this. A student once said, so that means that everything is true by default unless you can show it's false? And I don't think that that's a correct way to put it. You see, there's a rule of logic called the Law of Excluded Middle that says every statement is either true or false. Okay? And what we've done, let me actually take one step back. I'm going to put something here. I'm going to erase that last sentence. and I want to write this. The empty set is not a subset of A is false. Okay, so that means the empty set is a subset of A is not false. Therefore, it's true. Okay, so the student said, so it's like true is the default setting. And if you can't prove something's false, then it resorts to the default setting. And so you say it's true. And that's not exactly a correct understanding, okay, because of what I said a minute ago. There's a rule in logic called the Law of Excluded Middle that says every statement is either true or false. Okay? So if you have ruled that a statement is not false, then that automatically means that it is true. Not by default, but by the law of excluded middle. If it's not false, then it has to be true, because every statement is either true or false. Okay? So what we did was we showed that the statement, the empty set is not a subset of A. We showed that that's false. That's up here. So that means the empty set is a subset of A is not false, and therefore it must be true. Okay? So that's a theorem, actually. They listed in the book as fact 1.2 in the set theory and logic book. Okay? I'm going to just list it. I'm not going to number it, but I'm just going to list it as fact. For any set A, we have the empty set is a subset of A. Okay? So that's very important to remember. The empty set is even a subset of itself, because it's a subset of every set. Okay, now I want to move on and talk about how many subsets can a set have, and we're going to limit ourselves to finite sets. Okay? How many subsets can a finite set have? And let's just start out with an example. Let's write A equals, and let's just put the numbers 1, 2, 3 in there. Okay? And let's see if we can find all of the subsets. We already know of one. Well, actually, we know of two for certain. What have we said for certain? We've said that the empty set is a subset of everything. So the empty set is going to be a subset of A. And what else have we said? Every set is a subset of itself. Okay, so we know that's there. I think I'm going to put that one at the end because that's sort of the opposite extreme from the empty set. Okay, let's see, what else can I list? The set containing 1, that's a subset of A because 1 is in that set. That's the only element there. And 1 is also in A. Okay, what else can we say? We can say the set containing 2. We can say the set containing 3. So there's 4 subsets right there. What else can I say? How about the set containing 1 and 2? How about the set containing 2 and 3? How about the set containing 1 and 3? That's 7 of them so far. And then what else? And then there's A itself. Okay? Let me go back and put here, instead of the symbol for the empty set, since I've been writing all of these subsets out, I'll go ahead and write out the empty set too, which is brackets with nothing in it. So how many are there? There's 8 of them. Now if you look at this up here, do you think that maybe you find a formula for the number of subsets? There's 8 subsets of A which had 3 elements. So think about that for a minute. I had 3 elements in A, and I came out with 8 subsets. All right, now I'm going to show you. If you didn't think of a formula there, maybe you will if I show you this. What is a systematic way that I could make sure I get all the sets? You might have noticed what I did when I listed those out. I started with the empty set, which is nothing. Oh, I shouldn't say it's nothing. It has nothing in it, is what I should say. Then I wrote down the sets that have 1 element. And then I wrote down the sets that have 2 elements. And then I wrote down the set that has 3 elements. Okay? Well, how about if we went about it this way? Let's be very systematic about this. Let's draw what some people call a tree diagram. Okay? What if I say, okay, I'm going to start with the empty set. And then what about if I said this? Instead of saying, now let's write down all of the sets with 1 element, what if I did this instead? What if I said, let's look at the number 1. Okay? And I can decide to include the number 1 or not. If I do not include the number 1, then I'll still just have the empty set. I'm going to need more room. Let me draw that line more at an angle like this. If I do not include the number 1, then I'll still have the empty set. If I do include the number 1, then now I will have this set, right? Now, for each of those, now we go to the number 2. And we say, should we include the number 2? For each of those 2 that I have so far. Okay? If I include the number 2 here, oh, I should stick with the same pattern. If I do not include the number 2, then that would still be the empty set. If I do include the number 2, then that one up there becomes this set. Okay? Let's look down at this guy down here. If I do not include the number 2, then it stays the same. If I do include the number 2, then it looks like that now. And now we have 4 subsets. Okay, now let's move to the next element, 3. For each of those 4, we can decide to put in the number 3 or leave it out. So let's just start at the top. If I leave out the number 3, then that set will still be empty. If I put in the number 3, then it'll look like this. Let's go to the next set down that has a 2 in it. If I do put in the number 3, it'll look like this. And if I don't, oh, I'm sorry, I'm doing it backwards. I've been saying don't first. If I don't put in the number 3, then it'll stay like it is. If I do put in the number 3, it'll look like that. Okay? And now let's go to the next set down. If I do not put in the number 3, it stays like it is. If I do put in the number 3, it'll look like this. And then the last set at the bottom. If we do not put in the number 3, it looks like that. And if you do, it looks like that. And there we have all 8 subsets there. Okay? So if I do it that systematic way, then I can find a pattern here. You see, I asked 3 questions, starting with the subset. I asked 3 questions. Should I insert the number 1? And there were 2 possibilities, yes and no. And then I asked another question. Should I insert the number 2? And there was 2 possibilities, yes and no. For each of these. So in other words, for each of those possibilities, there was 2 of those. For each of those 2 possibilities, there is now 2 more possibilities. And so you have 2 times 2. Okay? And then for each of those, you ask the question, should you insert the number 3? And we got 2 possibilities, yes and no. For each of those 4, we had 2 possibilities. So that means we end up with a total of 4 times 2. So it went like this. 2 times 2 and then each of those times 2. So 2 times 2 times 2. And that's how you get 8 subsets. 2 times 2 times 2. How many times did I say times 2? 3 times. Why? Because there's 3 elements in A. And so you do this 3 times. You start with 1 set, which is the empty set. And then you double the number of sets 3 times. So you end up with 2 to the power 3. And so that gives us a very nice formula. Let's write this as a fact. If A is finite, then A has, and I'm going to leave a blank, subsets. And I'm going to write down how many subsets it has. How many does it have? It has 2 to the power of however many things are in A. And how have we been writing that? We've been writing it like this. The cardinality of A. If A is finite, then A has 2 to the cardinality of A subsets. Because of that idea that I just showed you with that tree diagram. You can find all of the subsets by starting with the empty set and then doubling the number of sets one time for each element of A. And so you get 2 to the power of however many elements are in A. Okay? All right, one more definition. If A is a set, the set of all subsets of A is called the power set of A. We're going to write that like this. A script P of A. That means the power set of A, and that's the set of all subsets of A. So going back to the example that we did a few minutes ago where I wrote A is the set containing 1, 2, and 3. Let's write the power set of A. We already listed all of the subsets of A. And so the power set of A is the set containing all of those subsets of A. So what were they? There was 8 of them. There's the empty set. There's the set consisting of 1. The set consisting of 2. The set consisting of 3. Then there was the set consisting of 1 and 2. The set consisting of 2 and 3. And the set consisting of 1 and 3. And then there was A itself. Those are the 8 subsets of A. So if I take those 8 subsets and I put them into a set, so that's like 8 small boxes inside of a big box, then that big box is called the power set of A. And how many elements are there of the power set of A? Be careful. Remember what we were talking about before. How many elements are there? There's 8. 1, 2, 3, 4, 5, 6, 7, and 8. This 2 right here is not an element of the power set of A, because that 2 is inside of a box, and then that box is inside the power set of A. So you don't see that 2 directly when you look in the power set. Okay? Now let's just do a couple of easy questions here. Some true or false questions. Just to see if you've got this. I'm going to write true or false. And I'm going to write some statements. Is 1 an element of this set? The set containing 1 and also containing, I'm not going to use the word containing here. The set that has the elements 1 and the set that has the element 1. That doesn't make sense if you have your eyes closed and you listen to it, but if you can see it while I'm saying it, then it makes sense. So is that true or false? Okay, think about that for a second. And then I want to ask another question. Is 1 a subset of that? And then I'm going to ask another question. Is the set consisting of 1 a subset of that set? And then a fourth question. Is the set consisting of 1 an element of that set? Let's decide if those four statements are true or false. Okay. So, is that an element of this set over here? Sure, I see it right there. So that's true. Okay, next question. Is this a subset of this over here? No, it's certainly not, because it's not even a set, is it? This is just a number. It's not a set. So it can't be a subset of anything. That's false. Okay, the next question asked, is this a subset of this? So let's see. Maybe it is, maybe it's not. There's an element of 1 in that set. Is that also an element of the other set? Yeah, it's right there. So that's true. Okay. Fourth question. Is this set itself an element of the other set? Yes, it's right here. That's also true. Okay, so 3 of those turned out to be true and 1 turned out to be false. Okay. I hope that makes sense to you. If it doesn't, come to the Zoom discussion and you can ask some questions and I can give some further examples. Let's do one more example before we stop. Okay, let me have you write out the power set of something just to make sure you can do that. So let's write the power set of the set consisting of this set and this one. How many elements are in that set? Not the power set. I'm just saying, look at this set right here. How many elements are in that set? You should be saying 2, not 3. See, there's one comma on that level. It's separating 2 elements. It just so happens that each of those elements are also sets, and the first one has 2 elements of its own, and the second one has 1. Okay? So, you see there's 2 elements of that set, so the power set should have how many elements? 2 to the 2, which is 4. We know the empty set is always one of them, and the whole set itself is always one subset. There must be 2 more. So what do you think they are? How about the set consisting of the first element, which is the set consisting of A and B? And how about the set consisting of the second element, which is the set containing C? So that's kind of a harder question. There's lots of examples in the book, and so I suggest that you read the book. Along with watching the lectures, you should always be reading the book, okay? There's lots of valuable information in there, and lots of valuable examples and exercises. All right, that's it for today. Have a good afternoon.